Good afternoon, everyone. Thank you for joining us today for the Introduction to HVAC Building Tune-Up and Commissioning webinar. My name is Beth, and I'll be hosting today's webinar. We'd like to start off this afternoon with a safety moment. Safety is a core value at PGE, and we would like to remind you to be safe around electricity. As you consider installing or retrofitting new equipment, please keep safety in mind. We would also like to encourage your family and staff to be prepared with an outage kit. And you can visit our website for more safety information. And that address is portlandgeneral.com/safety. We also want to thank the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support in co-sponsoring this series of free energy efficiency trainings that are open to all Northwest utilities and their customers. Before I introduce this afternoon's presenter, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see the chat window, and a polling window will appear at the end of the session. If you have any questions during the webinar, you can submit them to me through chat, and the instructor will answer them at the end of the webinar. At the top left corner of your screen beneath the Quick Start tab, you'll see some annotating tools, which I'll show you here, and I will circle them in red, including an arrow, a text tool, and a marker. And the presenter will ask you to use these tools on specific slides during the webinar. And now I'd like to introduce this afternoon's presenter. Greg Nelson is a professional engineer and certified energy manager at PGE. He is a mechanical engineer with more than 16 years experience in commercial and industrial systems design and operation. Greg focuses on finding energy savings opportunities within businesses and specializes in identifying energy efficiency improvement opportunities with businesses, schools, governments, and other nonprofit organizations. And with that, I'd like to hand the presentation over to Greg. Greg?
Thank you very much. I, too, along with Beth, want to thank you all for attending. And why don't we start it off with a little interaction. I'd like to ask you what description here defines your role best. And you'll find that most of the questions I ask you, most of the interaction I ask you for, you can use the marker tool for it all. But feel free to use the pointer or any other tool you see fit. Try it out. So I'm just going to wait a little bit and see if I get some responses from the crowd. So it looks like we have an energy manager out there. Energy manager, okay. And so as an energy manager, you may be familiar with a lot of the terms that we're going to discuss today and some of the topics. This is an introductory course designed to meet the needs of our customers. But feel free to ask questions through chat to get at some more of the nitty-gritty if you feel open to it. So it also looks like we've got a maintenance manager out there. So this crowd appears to be a little bit less diverse in as far as occupations go, so maybe I can try to focus it more on your goals. Okay, thank you very much for the input. Today, I'll be giving you a little background, terminology, and whatnot on tune-up and commissioning, and then we'll go into benchmarking. If any of you attended last week's webinar on energy monitoring, we touched on benchmarking, but I'm going to go into greater depth here today. And then we'll follow up with some basic tune-up concepts. And then, as Beth mentioned earlier, we'll have questions and answers. So diving into the terminology, I'll make this quick because it looks like most of you are going to be familiar with this. kW is a measurement of electric power. If we talk about a 100-watt light bulb being turned on, that's 100 watts of power required for that light bulb. If 10 light bulbs are on, that's 10 times 100, or 1,000 watts, which is equal to a kilowatt. If those 10 light bulbs are on for an hour, they will consume 1 kilowatt hour worth of energy. Power times time is energy. The energy term that we are concerned with on the natural gas side is therms, typically. But you also might run into therms when you're looking at either propane or some other fuel source that is serving your building. And then finally, BTUs. BTU is short for British Thermal Unit. It's a relatively small quantity. Typically, a BTU can be thought of as the amount of heat that's given off by a lit match. So, like, again, it's a relatively small number, but it's a useful unit that will allow us to use a common term to define the energy consumption of a building that may have a mixed use of fuels, either electric or natural gas or propane or whatever. And so just to give you an order of magnitude, another order of magnitude, there's 100,000 BTUs per therm, and there's 3,400, roughly kWh per, BTU per kWh. So again, BTUs is a small number, a small unit. Now diving into why would you want to tune up a new building? I mean, it's a new building, it's got new equipment. Shouldn't it operate just fine? Well, let's talk about the process of building a new building. Typically, a building owner or one who wants to own a future building will work with an architect to define, how many occupants are going to be in this building, what are their needs, how many desks do we need to put into the building, what about conference rooms, what about other support facilities if you're not an office, things of that nature. So conversations go on. From that point, the architect will work with an engineer or multiple engineers to put the concepts down on paper, get a design going for the building. And that involves iterations. Often there's schematic drawings followed by design drawings and ultimately bid sets. And so there's lots of conversations going on. If the engineer is fortunate enough, they may have a direct line of communication to the building owner to kind of hone their design to what the building owner wants. And then once the design is done, the architect and or the building owner will work with a contractor to put that design that's on paper and actually build it in real life. The contractor may have an opportunity to have conversations with the engineer, or maybe there's interactions like reviews of submittals. The contractor may see the design, think of an alternate way to meet the end goal, but the contractor still wants to get the engineer's approval to deviate from the original design, so they may ask the engineer for clarification on what type of equipment can be an alternate. And then finally, once the building is built, the building owner needs a building operator, and the building operator could be a person whose sole responsibility it is to operate the building, or maybe it's a person who has other duties. Maybe they're the financial analyst or some other role that takes their attention away from building operation, at least on a somewhat regular basis. So as you can see here, there's multiple lines of communication, and even if communication goes smoothly, there's always opportunity for misinterpretation or not quite following the true intent of the originator of the concept. The engineer may want to supply 55-degree air to the space, but maybe the contractor has put in equipment, or the building operator wants to operate at a different set point. There may or may not be any coordination on how that would affect the operation of the building. So moving on, why would you want to tune up an older building? I mean, it's been running. Shouldn't it be just fine? Well, we've got similar lines of communication going on. Let's think about a building that's been up for a while, maybe 10 years, and a tenant moves out and a new tenant needs to move in. The building owner will typically work with a contractor, and that contractor may or may not be the same contractor that did the original design. And that contractor will need to work with an engineer on many retrofits. Maybe you're changing a space from an office into a restaurant, or any number of relatively minor changes could drastically affect the way the building consumes energy. And then the building operator may have changed over the years, or the building operator may have had different assumptions as to what the new tenant needs and what the operating conditions should be in the space. So again, multiple lines of communication, multiple opportunities, or multiple possibilities anyway, of misinterpretation of intent, and that could translate into increased energy consumption. So tune-up and commissioning the intent of it is to reduce energy consumption in the building while still maintaining a workable environment for the building occupants. So I want to have another opportunity for you to provide some input here. What type of building or facility are you most interested in? So it looks like we got office, office. Okay. Well, I've got some slides geared towards office. It looks like maybe retail is of interest too. So I'll move on. I thank you for your input, and there'll be at least one other time I'll be asking you for more information. So moving on, if you look at the energy use profile of an office, and keep in mind this pie chart is geared towards offices that are located in the Pacific Northwest. So an office in California is going to have a different space heating requirement, for example, than an office in Oregon. So again, geared towards the Northwest, what we find is that in the typical office, we've got large energy consumption, or a large portion of the energy consumption will typically go to ventilation, space cooling, and space heating. Those are commonly referred to as HVAC, or heating, ventilation, and air conditioning. Another big consumer in an office building is typically lighting. But one thing to look out for is some offices have data centers or other large computing capacity in them. And so computers can become a big energy consumer, and both lighting and computers end up affecting your HVAC systems. They'll add heat to the space that the HVAC then needs to take care of. So those are the main energy consumers to think about when you're thinking about tuning up an office space. And again, not all offices are the same, so you have to kind of take this with a grain of salt and see, maybe make some assumptions or do some research to look into how energy is being consumed in your office space. Moving on, we've got energy use profile for a hospital. And what we could interpret from this, I recall that at least one of you was interested in retail space. So a retail space is typically going to be somewhere in between an office and a hospital as far as where the energy is being consumed. But let's get back to the hospital. Again, we've got a large chunk of energy consumption going to HVAC, but now we've got water heating. And water heating would also play a role in retail space, especially if you've got, cooking facilities and other, maybe if you've got a large restroom, you may want to pay more attention to your water heating consumption. But we still have lighting here also as part of the picture. And I guess that's enough to be said about that. I'll move on to the next. We've got one last pie chart I wanted to show you. And the key thing here with this pie chart is we're talking about industrial customers here. And you all can realize that there's more than one type of industrial customer. So the key thing here is in industrial environments, typically the biggest energy consumer is the equipment that's involved in the process, the industrial process. This could be compressed air. This could be dust collection. This could be refrigeration, for example, if you have a refrigerated warehouse space. So while lighting and HVAC can still be big components in industrial environments, you still want to concentrate on the industrial process equipment. So after that background on energy consumption in different types of facilities, I want to go into benchmarking. And like I said earlier, we touched on this last week in the webinar on energy monitoring, but this is going to go in more depth. The first step in benchmarking is tracking your own energy consumption. And down here at the bottom, I've got an example of a customer. This is a private school in the Portland area. They've taken monthly energy consumption. In this case, it's electricity, kWh, but they very well could have done this with their natural gas bills as well. And so they've got monthly data for a period of 3 years. And what they can see is that their energy consumption is steadily increasing over that 3-year period. And that may be natural. I mean, if you're a school, maybe you're adding portables or other square footage to your school space to meet demands. And so just because you see an energy increase, it's not an immediate need to sound an alarm. It's just something to think about. How can you mitigate the increase in energy if you know that there's going to be one? How can you control your energy consumption and ultimately reduce it over time? So this is a great concept for you to think about doing if you're not already doing it. Track your monthly energy consumption. But maybe you don't have time to do this. Maybe you're one of those energy managers that has other duties as well beyond energy management. You've got multiple options. For example, you could go to your utility's website and log in. PGE, for example, allows you to log in on their web page. It's on the right-hand side. You register your account by providing your account number and some other information. It's a pretty quick process, but once you get your account registered, you can log in and download up to 3 years worth of energy consumption for your site. And so you could pretty quickly get the type of information that you see down here. Northwest Natural has the same type of login process and download of past energy consumption. But even if you don't have time to do that, you can do a quick alternative, and I'll show you it here. On any utility bill, whether it be natural gas or electric, you're typically going to find a bar chart like this. And what this shows is monthly energy consumption in kilowatt hours per day, and on your gas bill, it's going to be more likely therms per day. But so from this graph, we can determine that our average energy consumption is somewhere in the neighborhood of 8,100 kilowatt hours per day. You do some quick math, 8,100 times 365. We find out that we're consuming just under 3 million kilowatt hours per year associated with this utility bill. Now keep in mind, one building may have more than one meter, or you may have multiple buildings that you're working on, so you may need to track down multiple bills, but it's still a relatively quick way to get at a rough but accurate picture of your consumption if you've got just a limited amount of time that you can devote to the task. So how can you use that? Well, if you're an office building, you probably want to compare yourself to other office buildings and see how you're doing compared to them. And one source of information that can help you get there is a report that's published by Northwest Energy Efficiency Alliance. This survey is done typically once every 3 or 4 years. The most recent survey was done in 2009, and I believe they're getting ready to post one here towards the end of this year. But this report looks at different buildings, different facilities, and asks questions of the owners and occupants. What type of occupancy is it? Where's the location? What's the floor area? What type of building systems do you have? What type of heating and cooling systems do you have, for example? So this report has a lot of pages, but it has a lot of great information in it as well. So if you want to find out some more information that you don't hear about today, here's another resource for you to look at. Yet another resource for energy consumption trends is the Energy Information Administration. This is basically the Department of Energy has this site, and they post energy consumption information based on their reporting and their research. And the EIA data is even more immense than the NEEA data. They go into occupancy type, census region, floor area, occupancy level, how many people are in the building, age of the facility, and the list goes on. Since it's broken into census region, here in Oregon, we're going to be in the West, but more specifically the Pacific. Now that's all well and good, but the data in there is grouped in such that our data is mixed in with Washington, California, Alaska, and Hawaii, all very different weather patterns in those different states and different regions. So while the data is is great, and as an engineer, I love to see more and more data as long as it's useful. We need to take that information that we find on this website and tweak it so that it reflects what's going on in our neck of the woods, basically. And so yet again, if you want to dig deeper into this issue of benchmarking and energy consumption in buildings, this is another website for you to check out. If you don't have the time to do that, what I've done is I've taken the NEEA information and kind of merged it with the Energy Information Administration information to come up with a table that I feel is pretty useful for commercial occupants to allow them to benchmark their energy consumption. And again, this is going to be more of a quick benchmarking, and I'll go into some more involved benchmarking here in a little bit. But over here on the left-hand side of the table, we've got different occupancies. A few of you said you were interested in office spaces. So a typical office in the Pacific Northwest is going to consume 83.4 kBTU per square foot per year. So BTUs are a small number. That's why we're looking at thousands of BTU per square foot per year. And that's all great, but you're not going to find BTUs on your utility bills, right? So what I've gone and done is I've taken that BTU and converted it to a kWh and a therm as appropriate, depending on the type of heating and basically fuel service you have in your building. If you're an all-electric service, you want to look here in this green section. So if I've got electric heat and electric water heating in my office space, I'd be average if I consume 24.4 kilowatt hours per square foot per year. If instead I've got natural gas heat, I would expect my consumption, my electricity consumption anyway, to be lower. And so that's at 16 on average, 16 kWh per square foot per year. But I'm going to now have some gas consumption, and that's closer to 0.3 therms per square foot per year. So how can we use this to quickly benchmark? Well, we just run some numbers. So let's say I'm a 6,200 square foot office building, and I did my research. I either did the quick graph assumption on what my annual energy usage was, or I've been tracking my utility consumption, and I determined that my typical annual energy consumption is 120,000 kilowatt hours per year. You do the math, you come up with 19.3. So that's 19.3 kilowatt hours per square foot per year. Now I want to ask you, is this good or bad? And so you can circle either good or bad based on how you feel that that number came out. I'll give you a moment to do that with your marker. So far we've got one good. I want to hold out for at least one or two more answers here. Looks like good, good. And we do have a bad. So I think that's enough input, but feel free to keep chiming in as we talk here. And my answer to this question is it depends. You know, is this office building heated with electricity or natural gas? Is my goal to be an industry leader and consume the least amount of energy than when I compare myself to my peers? Those give you different answers. If I'm an electrically heated building and I'm at 19.3, I'm performing pretty good because I'm comparing that to a 24.4 number. We're lower than that, and therefore our energy consumption is relatively low compared to an average office building. On the other hand, if I'm heated with natural gas, I'm comparing that 19.3 to 16.0. That 19.3 may still not be too bad because maybe I do have a data center in my facility, or maybe my bottom floor is actually retail or restaurant space. There can be any number of reasons that this 19.3 number could be good or bad. That was the quick benchmarking. Now I want to go into a little bit more detailed benchmarking that will allow you to get at some of those nuances. You know, do I have a data center? Are my hours of operation different than the typical office space or typical retail space? One of the best tools, and I'm going to show you actually two different tools from the Energy Star website. Some good quick tools to give you a more in-depth benchmarking can be found on Energy Star. One is Portfolio Manager, and Portfolio Manager would be geared towards those of you who know you want to track your energy consumption over time, and you do know that you want to make sure that you're continuously improving over time. And so Portfolio Manager gives you the opportunity to enter monthly energy consumption and gives you a real detailed benchmarking, and maybe will allow you to ask yourself the questions that'll help you dig really deep and really fine-tune your energy consumption. Portfolio Manager and the other tool that's available on the Energy Star website, the other tool is called, I've lost it, but we'll highlight it here in a little bit. The two tools on the Energy Star website will be geared towards commercial facilities, and so these are the types of facilities that you can use the tool on. And so moving on, how do you get to the tools? Well, you go to energystar.gov, you click on Buildings and Plants, and then you'll come to a page that looks like this. So the two tools that are available are Portfolio Manager, like I mentioned, and then Target Finder is the other tool. Target Finder is going to be for those of you who just kind of want to dip your toe into the benchmarking scene and see if it's for you. Target Finder can be done in somewhere in the order of 10 minutes, as long as you've done a little bit of homework up front. And to give you a feel for what type of homework you need to do, I'll move on to the next slide. And so this is sample inputs for Target Finder. In this case, I've got a sort of a hybrid building where I've got some office space, I've got a warehouse that's unrefrigerated, but then the bulk of my facility is a refrigerated warehouse. I've entered the square footages of my different spaces, and then I've got my total here to kind of check and see if it makes sense. Then I've gone in and I said, okay, for my office space, what are my hours of operation? How many employees are on the main shift? How many computers are there? And then how much of that space is heated and cooled? These are all questions that this tool is going to ask you in a manner that allows you to enter the input quickly and yet get a pretty decent benchmarking of your facility. Moving on to the other space that I've got, or another space that I've got in the building, the warehouse, the unrefrigerated warehouse. Again, how many people are there typically? What are the hours of operation? And what's the heating? And what's the cooling? In this case, I've got no cooling, but I've got some heating in the warehouse space. So probably those unit heaters that you see up high in the ceiling space. Moving on to the refrigerated portion of my building, how many workers are there? What are the hours of operation? And so you can see that we've added some more detail to our benchmark, and we've told it we've input more than just one space. We've given the tool some idea for how many people are in the space and how many hours they'll be there. But you can probably tell that there's some missing information, right? A refrigerated warehouse, for example, is going to consume a different amount of energy if it's a cooler or if it's a freezer. Freezers are operating at lower temperatures, therefore the compressors in the refrigeration system are going to be working much harder than those in a cooler or a traditionally refrigerated type space. So based on those inputs, here are the outputs that I get. If we look at this design section of the table, this is the performance of my building as I've defined it. I've told it how much energy I've consumed for my building. I've told the tool what my building is made up of as far as people and operating hours and space types. So my building scores a 70. In Target Finder and the other tool on Energy Star's website, the number 70 implies that my building performs 70% better than 70% of the buildings out there that are comparable to mine. The same number of square feet of refrigerated warehouse space, along with that small amount of office space and a decent-sized non-refrigerated warehouse space. So at a glance, you can see, okay, I'm better than 70% of my peers. Maybe that's good enough for you, or maybe you want to set yourself a target. In this case, this customer is saying, well, I want to be better than 80% of my peers. And it can give you a feel for how much you need to reduce your energy consumption. So we have to go from over 17 million kBTUs down to 14 million kBTUs. And if you don't like using kBTUs, we've got your design energy consumption down here in therms and kWh. So this tool is not only a way to benchmark your facility, but it also gives you some hands-on things you can experiment with and gain knowledge on energy management techniques and tools. So both Portfolio Manager and Target Finder are geared towards commercial facilities, like we said. But if you are an industrial customer, there are some other pieces of information that you can find on the EPA website. There are benchmarking techniques for different industry types. I think you'll find if you dig into that section of the Energy Star website, you'll find that most of the industry types represented don't exactly match the types of industries that we typically have here in Oregon. But you still may find some of that information useful. You can also dig deeper and find information on compressed air systems and motors and process heating and pumping and steam. If you want additional information that you don't readily find on the website, feel free to talk to the PGE contacts that I'm going to give you later on in the presentation. So one last time, I'm going to ask you for some input. What describes the facility or building that you are most interested in? Is it 1 to 2 stories? Is it more than that? What's the square footage? And this is going to help me get a feel for what types of mechanical systems and lighting systems you most likely have in your facilities. So 1 to 2 stories. Typically a 1 to 2 story building, for example, is going to have either packaged rooftop equipment or split systems. The 3 floors or more are typically going to be more of a built-up mechanical system where you got fans and custom coils. So all those things have different methods of tuning, but most of the concepts that I'm going to talk about moving forward are going to be geared towards any type of facility. Great. Thank you for the input, and I think that's the last time I'm going to ask you, so you can put your pens down if you'd like. So let's talk about levels of commissioning. If you think of commissioning as something that you put on a scale, a basic tune-up is going to be on one end, and then full-blown commissioning is going to be on the other. Basic tune-ups are things that I think of that can be performed by a customer. They don't necessarily have to be an industry expert or have experience in the different energy-consuming devices that are in a facility. They can start making some changes through some basic tune-ups that can affect and improve their energy performance. Moving on to full-blown commissioning, typically a specialist is going to be required, and often when we're talking about commissioning a big building, it's preferred to have a third party come in and help you with that, because it kind of takes some of the emotion out of the equation. If you've got a building operator who's been operating a building for 20 years, they more than likely can help you commission your building, but they may not want to dig too deep into areas that either they are not experienced in or that they feel might paint a bad picture of their performance. And then while I say basic tune-ups can be performed by a customer, that doesn't mean that they have to be. If you don't have enough time to do some tune-ups, maybe it would make sense for you to contract with someone to help you do those tune-ups. And typically when we're talking about tune-ups, it's not a one-time thing. It's a monthly, potentially monthly, or at least annually ongoing thing that needs to be done. So let's get into the basic lighting tune-ups. Lighting, as we saw earlier, can be a big energy consumer in almost any occupancy type that you are operating in. And one thing that you can do to control your lighting energy use is to utilize occupancy sensors. And just because you have these installed doesn't mean you don't need to make any adjustments to them. I've been into many buildings where the occupancy sensor in the conference room, for example, will turn on and off the lights purely based on what's going on out in the hallway and not so much based on what's going on in the room. And so if that's happening at your facility, maybe you want to look at where this sensor is pointing. You can often change the direction of this to make sure it's looking in the proper area to sense activity in the room in which the light is being controlled. Another thing to dig into is to see what sort of modifications you can make to the timing of the occupancy sensor. You know, maybe your sensors are tuned such that they only turn off the lights after 20 minutes of non-movement. Maybe you want to tighten that up a little bit to 10 minutes or 5 minutes. And then maybe you want to have it ask or, you know, scan the room once every minute to look for any changes in activity. It all comes down to what type of sensor you have, dig into the paperwork, dig into the operating parameters and the adjustments you can make, and adjust those settings to meet your needs. Time clocks. Time clocks can come in different forms. You've got an older version represented here, and maybe you've got a more advanced control system in your facility. Regardless of what type of time control you have, there are opportunities to continue utilizing that. I mean, at first glance, this time clock here may appear outdated, but it may serve its purpose very well. Typically, you're going to see these types of controllers on outdoor lighting, or maybe even possibly some fans in areas of the building that are not continuously occupied. The key thing with these older style time clocks is you want to just pay attention to where these tabs are located. These tabs are the signals that mechanically trigger an on or an off of the equipment that's being controlled, whether it be lights. Maybe it's going to turn on the lights when it's 8 o'clock p.m. and then turn off the lights when it's 2 o'clock a.m. or whatever. Understand what your schedule is. Make sure that this time clock is meeting your needs. And your needs may change over the years, over the months even, especially if you're talking about controlling outdoor lighting. You know, we're entering a time of the year when the days are getting shorter, and they'll get shorter and shorter and faster all the time. You know, in the spring and fall, you may need to be looking at this time clock once a month to make sure it's tuned properly to what you need. Replace failed photo sensors. You can often see these pretty readily if you pull up to a building, for example, and their outdoor lighting is on in the middle of the day. It could be a failed photo sensor. It could be a dirty failed photo sensor. So either clean it or get it repaired to optimize your lighting energy use. Sweep controls are typically found in larger buildings. So if you have sweep controls, the key there is to have multiple sweeps. And why don't I kind of step back and describe what sweep controls do. Typically, let's talk about an office environment. Typically, the occupants are going home around 5, maybe a few people stay till 6, but maybe in your building, people aren't there much after 7. So your sweep controls can automatically sweep off the lights or turn off all the lights other than your emergency egress lighting. And it'll sweep those non-essential lights off at 7 o'clock or whenever you feel it's appropriate. That's a great way to control your lighting energy consumption. The thing that you want to think about, though, is if you have sweep controls, you probably want to institute multiple sweeps. Because what happens at 7 o'clock if somebody's still in their office and the lights get swept off? Well, that occupant will end up turning their lights back on and maybe several other lights just to make sure that they feel comfortable and safe in the work environment, they can get their work done. So that's why you probably want to sweep the lights off again at 9 o'clock and then maybe again at 11 o'clock, just to make sure that you get those stragglers out of the building and you get your lights turned off as soon as possible. And then finally, zoning. When you're looking at tuning up your lighting energy usage and tightening up reducing it as much as possible, you want to look at zoning. Many times when you redesign a space, you may not have been able to change the location of a light switch. I've been in some areas where a light switch in the closet ends up controlling lots of lights throughout the facility. And so if that light switch is inconvenient for your occupants to get to, they're more than likely not going to turn it off. They'll leave it on more often than they need to. So consider zoning, consider relocating fixtures, or I'm sorry, switches and other controls that are not in convenient locations. And then another part of the lighting tune-up is considering a maintenance plan for your lighting opportunities. You want to clean fixtures. If a fixture is dirty, whether it be the lamp itself or the reflective surfaces, that fixture is not going to put off as much light as it can. And if your occupants feel like there's not enough light in the space, they're going to end up bringing in their own fixtures or turning on extra task lights and whatnot when they may not need to. So when you go up there to change out lamps, you probably want to clean the fixtures as well. Measure light levels. This is pretty important, especially if you haven't done it before or you haven't done it since a lighting retrofit. Many times when older lighting gets replaced with newer lighting, it's just replaced one for one. That is, one lamp, one older inefficient lamp is replaced with one more efficient lamp, and the quantity of light fixtures doesn't change. But what you might find is that when you upgraded to that more efficient light fixture, you got more light than you had before. So maybe you're overlighting a space. But underlighting, like we talked about in the clean fixtures bullet, is also a danger because the occupants may need to bring in their own lights or turn on extra lights to create a safe work environment. And safety, of course, is very key too. Replace T12s and older T8 fluorescent fixtures. If you've got T12s, and a T12 fixture, basically the number refers to the diameter of the lamp. A T12 is 12/8 of an inch or 1.5 inches in diameter, and a T8 is about 1 inch in diameter. So you can kind of do a quick measurement to see what type of lamp you have if you don't know already. And you don't have to go up on a ladder and measure the size of a lamp that's in an operating fixture. You can probably go to your stash of replacement lamps and either check the box for the type of lamp or measure the lamp that you've got. A T12 is typically going to have a magnetic ballast, which is really inefficient compared to the newer technologies, the electronic ballast that you have on newer fixtures. And then even T8s, even though T8s are a relatively efficient fixture, we have customers going to T8s all the time. The first generation and second generation lamps are not quite as efficient as the most recent generation of lamps. So if your light fixtures are over 10 years old, it could be a good opportunity for you to change those out. Moving on down the list, replace HID fixtures. These are the fixtures that you typically see in high bay applications, whether you have a warehouse or maybe it's a big box retail or something like that. A fixture is located maybe 20 feet up in the air. It's typically going to be a round fixture with a box on the top of it, and that box is essentially the voltage controller. But those types of fixtures can really, you can improve your performance if you replace those types of fixtures with either T8s or T5 fluorescent fixtures. And even LED fixtures are coming on the market that are cost-effective and good replacements. Then replace older ballast. Like I said, the T12s are typically going to have a magnetic ballast, and newer ballasts are electronic and help you reduce your energy consumption. The ballast is the voltage controller for the lamp. And then group relamping. If you've got fixtures that are located high up in the air and one bulb goes out in a fixture, or one lamp goes out in a fixture that maybe has 4 lamps in it, if you have to rent a lift or some other method of getting up to that fixture, it may make sense for you to replace all the lamps all at once, recycle the old lamps, put in the new ones. That can help you reduce the labor associated with relamping, changing out old lamps. And depending on what type of fixture you have, maybe you can afford to let 1 or 2 lamps burn out before you start replacing a bunch. So that's the lighting. Now I want to move on to HVAC tune-ups. But like I said before, if you improve your lighting, you're going to help reduce the load on your HVAC systems. So don't look at that, 10 to 15, 20% energy consumption of lighting and compare it to the 50% energy consumption of HVAC. Lighting is a double whammy. You get a double benefit for doing those change-outs. But when we talk about basic tune-ups, typically we're going to be talking about this type of equipment that you see here. It's referred to as a packaged rooftop unit. And like I said before, typically this is going to be on buildings that are 1 to 2 stories high. But even a lot of these things that we're going to talk about are applicable to larger systems or different types of HVAC systems. So as part of your HVAC tune-up, you want to, again, like the lighting systems, you want to implement a maintenance plan. You want to regularly check temperature set points. Many spaces are going to have a programmable thermostat. What you want to do is make sure the temperature set point meets your needs and that the time is programmed correctly on this screen here. I don't know how many buildings I've walked into where the time isn't even close. It's not a matter of daylight savings time being missed. Sometimes those time clocks are off by 13 hours, and it's actually a Monday, but the thermostat thinks it's a Saturday. And much like the lighting, if you have low light levels, people are going to bring in their own methods of lighting the space. If you've got uncomfortable temperature conditions, people are going to bring in those heaters and turn them on, and you won't have as much control over a personal heater as you do over a HVAC system serving a larger space. So check those set points, check them often, because your occupants, they're pretty ingenious. Even if you've got the thermostat locked away, or if you've got a code you've got to enter in order to make any changes, the occupants find a way to make changes and at least attempt to make their lives more comfortable if they feel uncomfortable. Change filters per manufacturer recommendations. Now, this isn't going to typically make a huge difference on your electricity consumption, but it could potentially prolong the life of your equipment. So while you're at it trying to save energy, you might as well save costs by prolonging the life of equipment. And then clean equipment per manufacturer's recommendations. This here is a picture of a condensing unit. Typically you'll see these on split systems where you have a furnace section or a fan section inside the building with refrigerant lines piped to this condensing unit. And what this condensing unit does is it allows you to reject the heat out of the building when you're cooling your space. You're evaporating refrigerant within the space to cool down the air within the space, but then you've got to condense that refrigerant back to a liquid to continue the process of refrigeration. So that's what the condenser does. It takes that evaporated refrigerant and condenses it down and cools it down with the use of a fan outside. But if these coils here are dirty, the fan isn't going to be able to remove as much heat as it could if those coils are clean, and those fins. There's fins on the outside and coils on the inside. But the key here is to clean those per manufacturer's recommendations. You don't want to take a pressure washer and have at your condensing units. If you bend the fins, if you break the fins, if you damage the coils, it too is going to affect the performance of your system. And again, cleaning this stuff may save you energy, but it's more than likely going to help you prolong the life of your equipment. And I should say, it will save you energy. It just may not show up on your utility bill, depending on your consumption patterns. Other resources that you can refer to are here if you want to dig a little bit deeper into commissioning. And even if you want to dig into, tune-up opportunities, these different resources, while they're a little bit old, here's one from 1999, and here's one from 2000, 2001, somewhere in that range. These are great resources. The Oregon Office of Energy, which is actually the Oregon Department of Energy, has a great set of resources. FEMP is the Federal Energy Management Program. They've got some good resources. They're all out there, and so do your own research if that's something you want to do. So to close out, I wanted to point out some people you can call if you're interested in doing an energy efficiency project. And I should point out that many incentives that are available through the Energy Trust of Oregon will require some form of pre-approval before you start. Now, depending on the size of your project that you want to do, you may not have to pre-approve your project, but you might as well, ask the question, do I need to pre-approve? And some people that you can ask the question of is Paula Conway or John Maloney, depending on the type of customer you are. Paula Conway will help you if you're a commercial customer, and then if you're an industrial customer, contact John Maloney. Also, if you're more of a do-it-yourselfer, you can go to the Energy Trust website. They've got a list of trade allies, which are contractors in the area that are familiar with the Energy Trust programs, and often they can help you do particularly smaller projects, but even larger ones. They can help you with the paperwork. But like I said, if you want to talk to somebody in person and get some ideas for good next steps, these are the folks to call. So with that, I will hand it off to Beth.
Thank you, Greg. And I'm going to just would like to remind all of you about some upcoming webinars and seminars that we have. And you can visit our website at energyeducationcenter.com to find out more on these and other opportunities. Greg did mention some lighting opportunities. We do have a lighting webinar next week on the 29th. And we also have some seminars in September, human-centric lighting and LED indoor and outdoor lighting on the 25th. Before we proceed to the question and answer portion of the webinar, I'd like to remind everyone that you can continue to submit questions to me through chat, and I will ask them of Greg. Within a few days, we'll be sending you a follow-up email with a recording of this session and the PDF of the materials. And right now, I'd like to draw your attention to the polling survey, which I have just opened at the bottom right-hand corner of your screen. If you could take a few moments to fill that out, we do value your feedback and use it to improve future webinars. And now I'd like to proceed to the question and answer portion of the webinar. Greg, our first question is, can you suggest some resources for a novice non-engineer to identify inefficient HVAC systems for large commercial buildings?
Yeah, there's several resources you can go to. You can use some of the tools we talked about today. Typically in commercial environments where maybe you want to get your feet wet into the realm of mechanical engineering. Typically in those type of environments, you're going to expect to see higher energy consumption, at least higher electric energy consumption in the summertime. And that's typically going to occur 4 months out of the year. We live in a great environment here in the Pacific Northwest where we've got relatively cool temperatures, moderate temperatures year-round. And as part of that, many HVAC systems allow you to take advantage of that through their economizers. An economizer is a set of dampers and temperature sensors that allow you to use outside air when it's cold enough outside to help either offset or completely eliminate the need for traditional mechanical cooling with compressors. The economizer, for example, will open up and pull in outside air if it's 55 degrees outside. Typically 55 degrees is about what you need to supply if you're trying to cool a space down. And it's 55 degrees half the time here in the Pacific Northwest. So look into economizers. If your systems have economizers, don't immediately assume that they're functioning. I've seen some reports out there that upwards of 50% or even more economizers don't function properly. We're talking about lots of components inside the HVAC system and inside the economizer that have to be working in order for the system to work properly. We've got dampers that are going to be controlled by some actuators, or effectively small motors. And then we have temperature readings. If any of those temperature readings are wrong, or if the actuator gets jammed, the economizer is not going to function properly. And so what we should see is a relatively flat energy consumption from November through May. If we look at our annual energy usage graph that comes on our utility bill, if you're not seeing flat energy consumption there, that's a good indicator that maybe you should look into your economizer. If you're just getting your feet wet, though, in HVAC systems, maybe that means you need to ask a contractor to help you ascertain whether or not your economizers are functioning, or even if you have economizers. Another good thing to do is to set back your temperatures on your systems at night. If your building's not occupied, you don't need to maintain occupied temperatures. Typically, in an office environment, for example, you want to heat to 70 degrees and maybe cool down to 74. You want to have a temperature band between your heating and cooling set point of probably about 3 degrees, if not more. But then at night, you want to set your heating down to 60 degrees, and maybe you're cooling up to 80. Different mechanical systems, different ductwork are all going to affect how your system works, but you can play around with those settings, and in general, set back your temperatures when you feel like everybody's typically gone home, and then go back to your occupied temperature set points about an hour before you expect people to come back into the building. You want to get that temperature back up to those occupied set points by the time people get in. That was a long answer. Hopefully it meets your needs.
Great, thanks, Greg. And our next question is, when it's time to replace equipment, how do I find the best, most efficient option for the equipment that I'm replacing?
Yeah, so the easiest way to do it would be to look for ENERGY STAR certified equipment. This would be typical. You could typically find this for water heaters, for furnaces, for a lot of HVAC equipment. And so the ENERGY STAR rating system will show you how that piece of equipment compares to all the other pieces of equipment on the market. That's the quick answer. The other thing you can look into is what is the efficiency rating on the equipment, and unfortunately there's not one standard efficiency number for heaters and for water heaters, for furnaces, for HVAC systems. But typically, if you're talking about HVAC equipment, you want to look at either a SEER or an IEER number, and in general, the higher the number, the better the efficiency is. With furnaces, you're typically going to be looking for an AFUE, or an annual fuel usage number, basically, and that is going to be a percentage, and again, you want that percentage to be as high as possible, because that tells you how much how much gas is being used to convert heat that's used in your space. Typically, you're going to see an AFUE of maybe somewhere in the 90% range, and some higher, some lower. But what 90% means is that 90% of the gas that's burned turns into heat that is useful within the space. The other 10% goes up the flue. I think that's a long enough answer for that one.
Thanks, Greg. And that was our last question. We'd like to thank all of you for joining us today, and I'd like to hope that you can join us at a future webinar or seminar, and we'll stay online a little bit in case you have any additional questions. And thank you again.